Alright, so I got
talking about nothing anyway.
a third question going up there.
I got so much water in my backpack. How about salad around
Silence your phone.
I had to my AirPods out. No.
It is silence. Okay.
Oh, Hassan.
Alright. So, the trend line,
need to go down.
Khalil, is that you on the first two questions? Is your question with the trend line about how to create that trend line?
No, you just press alphabet X and you just start.
No.
So one of the things, so it's this question, right, at the beginning, or is it the questions 3 through 5? Number 3? Okay, we'll talk about this. Now, I need some of us to pay attention, because I know one student specifically in this class who should have asked about this one. First off, y'all need to be careful with numbers 1 and 2, because what was the independent variable, the input, according to the understanding check?
Candies.
No.
Wait.
Yeah.
Look at that sheet again. Where,
Candy-
by the way,
Candy Grab.
Hobson, yours is over here.
Candy grab.
Eric's, where is yours? Where's your understanding check? Never even got it out. Hobson, yours is over here, if you wanna come get it. So that you can take notes and learn from your mistakes. Chase, if you could, grab a seat for me.
So that's what we're doing, maybe just reviewing the right sheet.
No, we're just spending a couple of minutes on this before we start today's lesson. But we have made mistakes and we need to learn from those mistakes. There he goes. So you see how you probably should have asked a question on numbers 1 and 2? Okay,
I don't know my understanding check is.
now, I need y'all to look at this.
Yeah, I can't find it.
Okay, then grab a seat and just pay attention to go over this. So, remember, we need to make sure that we pay attention, because what does it very clearly say is the input or the independent variable in number 1?
Oh, wait.
The weight. And what was the dependent variable? Candies.
grab.
I intentionally created, you did not have that correct. That's why I'm telling you to pay attention.
The independent variable is weight.
Bring them all to go.
It is, you did not do that on your calculator.
I saw it.
So, I want y'all to look at this file that I have from that day. Oh,
This show mine.
this is it. So, remember you had to go in, you had to, nope, there. You had to pick them up and put them in your backpack and don't get them back out, Khalil. Come on, you know better than this. Scatter plot. So it was weight, and then, actually let me do this. If you did candies and then weight, it was gonna mess you up. Here's how. 1, that's not independent and dependent, that is incorrect. So I'm gonna hit enter, and when I hit menu and zoom to data, there's the data, right? But you're supposed to be creating a what? Along with that data.
Yeah.
Well, that is the scatter plot. What else did you need to do? Number 2, create a.
Wait, is it not backwards?
I know. You need to create a what? Linear model or trend line. So you would have had to type in an equation in this way. But if you had flipped this so that it was weight,
I need candy anyway.
I know, and that messed you up. If you had done weight and candies as the independent and dependent like you were supposed to, see how there was a linear model that was already going through that window? I did that intentionally so that you already had something to work with. Now, the student who did this linear model, is that model appropriate for that data?
No.
You gotta.
Why not?
It's not like.
It's not showing the trend. It's kind of going through the middle, but it's not showing a trend. Remember, when we show a trend, we should not have groups like this. Right? You cannot have groups like that. It needs to be scattered around the linear model. So keep that in mind. One of the things I want to point out here is this. The student who did this one made the note, well, Mr. Kinney, I can't get the slope to work correctly. Which notice, can we get the slope to work correctly here?
No.
Not really. What were you supposed to change first, guys?
The y-intercept.
Right, you should have changed the y-intercept. Now, try to rotate. Okay, still not working great, but I'm gonna change my y-intercept again. And then, it's getting better. Change the y-intercept again. Now, do I have a pretty good linear model?
Yeah.
Yeah.
It's pretty decent, right? Notice it's going through the data. Notice also, are there groups? Or is it is the data just scattered around the data? It's scattered along the line, right? It's not, it's showing the trend in the data, things like that. So please pay attention to your independent, dependent variables. I'm going to give you a linear model somewhere near the data that you can transform on the test, so pay attention to that. All right, so I know for sure we already had, so Khalil, what was your question here with the linear models for number 3, or numbers 3 through 5? Was it that you didn't know how to interpret the slope and y-intercept, or didn't know how to identify the slope and y-intercept?
Look, I had said, well, they say you said, why is it you can, candy?
Ah, so why is the candies dependent? So that's what you're referring to. So that's a great question. Looking at context, we should know very quickly, right, that my independent variable, which is also x, is height, but we should have more than just that. Dependent, or y, was candies, right? And one of the things I said here is include how you know what the variables are to demonstrate the depth of your understanding. How did we know that candies is dependent? Say it again, Khalil. Say it louder.
Why?
When you say the y, what do you mean?
Output.
Okay, but how do you know it's the output? Like, I think you might be there, but I want to hear you. Okay, is that what you're referring to, this right here?
Yeah.
Okay, and so you would want to say that, right? In the scatter plot, candies is the y, it's the output. That's one way we know it, right? And that would have gotten you most of the credit. Does anyone know what else I was looking for, though, to confirm that the candies was, in fact, the output, or the dependent variable? If I reach in and grab these markers, what's going to determine how many markers I can grab?
The size of your hand.
The size of my hand. Well, isn't the size of someone's hand also connected to their height? Which is what this problem is all about. In general, the taller you are, the bigger hands you have. That's just truth. Okay? So, the number of candies grabbed depended on a person's height. That was the other thing, Khalil, that we know that the number of candies you could grab out of a bowl depends on how tall you are. Hello.
Give me some food, bro.
Doing good. How about you?
What you do, nigga? I need stuff. What you do, nigga?
Okay.
She pointed at you. What is it? I said you nigga stuff. You gonna check his ass? I'm saying you pointed at him.
Can I come down to here and forth while I can talk about it?
Oh, God.
Starts at 140. No worries. Yeah.
Like, this is.
No worries. Yeah. That's perfect. Sounds good. Thank you. Bye. Okay. So, again, the number of candies that you could grab out of the bowl depends on how tall you are, right? That's a way to notice it. And really you had to talk about both of those, Khalil, to get full credit or the full mastery, but you could get a 5.5 out of the 6. Remember showing me clear, consistent, and convincing evidence of your understanding without noting all of that, right? So don't forget that those rubrics are about the evidence that I see of your understanding, okay? Now, you do want more context than just height and just candies, and that's going to impact how you interpret these. This is the height of a person in what? In centimeters, based on the context. So you actually had to go back to the calculator. Remember, that's not up here.
Express it like that.
Well, you want the full context, right? It's not just height, it's how tall the person was specifically in centimeters. Notice along the x-axis, do you know anyone 150 feet tall? You know anybody else, anybody that's 150 inches tall even? 150 inches would be
Well, that's
roughly,
like
4.
that's like 12 feet tall.
Yeah.
12.
Yeah, anybody who know 12 feet tall?
Gazel.
12 and a half? So notice, this is why it's important to note that it's the height, hey guys, height of a person in centimeters is what we refer to. Okay? So what was the candies? It's not just candies, it was the candies that was grabbed out of the bowl. So candies grabbed from bowl, right? And that depended on how tall someone was. And so Chase got really bent out of shape and was like, Mr. Kinney, this doesn't make any sense when he got to the y-intercept, which he's correct. Now, I need y'all to be careful because I saw a couple of us talk about the y-intercept as 14. But remember, the y-intercept is when the input is 0. Is this input 0 right here? No. You had to go to the linear model to get the y-intercept. Y hat equals 0.45x minus 53.4. So remember, what's the slope in this equation? The slope is?
Oh, no, slope is 0.45.
Remember, slope is the constant additive rate of change.
Yeah.
Multiplication is repeated addition. Okay? You can also see it like this. And then the y-intercept, now, it's not just the negative 53.4, it's the 0, comma, negative 53.4. So, Chase, what was the issue you had when you were interpreting this y-intercept?
Because the way you have to write it, because they can go there, like they have to give back candy.
I'm sorry. It's okay, you're a tough boy.
Cool.
You're about to leave in
Cool
all
ass
of
room.
8 minutes. Just hold on for 8 minutes. Okay? So 0, comma, negative 53.4. Now, I need y'all to pay attention to this because this is why it's important to define your variables well. Notice we have numbers here. We need to put these in the context of the problem. 0 is an x value. So 0 what?
Height of a person
So the height, if the height of a person
increases.
is, well now be careful, hold on, you said increases. Is this all about change or increasing and decreasing?
Oh, that's what you put on mine. You changed it on mine.
Not for the y-intercept. Remember guys, what deals with rate of change? Is it the y-intercept or the slope? Slope is rate of change. And so Chase, if you look at the slope for number 5, unless I made a mistake, but I'm pretty sure number 5 with the slope is where I talked about the
I
increase.
put rate of change. I put like,
So,
like for the, when I wrote this thing out, where is this thing at?
so if a person is 0 centimeters tall, then what would we conclude? Somebody, anybody?
What you say?
If a person is 0 centimeters tall, then what would we conclude? Based on this y-intercept.
What the Y?
The y, which is,
60.4.
but that's how many candies were grabbed. And also it's not positive, it's negative. So if a person is 0 centimeters tall, then the model, then,
Oh, you did it for slope. My bad.
right, because slope is rate of change. So then, how would I word this? Then they what?
Then they would have to give, or the model predicts they would give 53.4 candies back.
And so then the model
It makes no sense.
predicts the person gives the bowl
Candy.
53.4 candies. Now, what you could have done is you could have just said predicts the person grabs negative 53.4 candies.
That'd make it even.
Kinda.
Okay. So, guys, you're too old for this. We're in high school. Act like it. So, here's the thing, and Chase is 100% right. This makes no sense. However, let me point this out. Can a person be 0 centimeters tall?
No.
So the y concept as a whole in this problem doesn't make a ton of sense. And that's okay, we're not determining whether it makes sense or not, we're just interpreting it and getting practice interpreting it. It doesn't make any sense. Because this cannot happen. If you look, and this is one other thing to pay attention to, you don't really want to go too far outside of your data set. What is the lowest x value that we have? Like 140 something? 0 is super far away from 140. Right? So that's called extrapolation, going outside of the data set you have. That's why it doesn't make sense. Okay? So it's perfectly okay that it doesn't make sense. Alright?
Did they move the y-intercept over so we could see it?
No, so I zoomed to the data. Right? So I zoomed to the data, then I fit a line to the data. Right? So remember, if you look at the one scatter plot we did earlier, it would no longer have the y-intercept as well because you had to zoom to the data. With your slope, be careful. Oh, by the way, I'm glad Chase pointed this out. Remember, the output, the y, is always a prediction.
Well, you put that on mine.
So wouldn't the slope be like 0.34, then you got the tight.
Well, the slope is what for this problem? What is the slope?
0.
Not for this one.
Slope?
Remember, the y-intercept was negative 53.4, the slope was
0.45.
0.45.
Oh, 0.45, then you put the 1 under it.
So remember, we need the 1 underneath, because how do we calculate slope?
And then you got to change it to y, and change it.
Right.
Try it off.
And so remember, one thing we might want to consider is the y hat. And so Chase, that's why I talked about the fact that you need to say increase, because it's a change in the x. It's not the x and y itself. It's when, what is x referring to? The height. So when the height increases,
I was kind of confused why you circled those. I was like, when I looked.
so when the height increases by how much? By 1 centimeter, then, and so then you need to pay attention to the y. The y is all about the
Candles.
candies grabbed. Okay? Then the model predicts a person to grab how many more candies?
0.45.
And so Chase, in general, we have to recognize that these are models predicting things, they're not exact. So we are going to get weird values in the first place. Okay? Got that?
About time to go.
It's 100% about time to go, but I want to take time to answer y'all's questions. So we are just a hair behind. I know Cam's going, Mr. Kenny, how are we behind? It's okay, Cam. We'll be all right.
Like every day we get behind.
I'm going to adjust a little bit of our instruction today to try to get us caught back up.
Hold on, Miss, don't raise that stuff to the left.
I did it for a reason. Okay. So what I want you to be aware of, okay? Wait, first off, who doesn't have their textbook with them?
You said what, Biscuit?
Anybody else besides Chase not have the textbook?
I got mine.
You got yours, or you need the pages?
I'll tell you my backpack.
What are you writing?
You have it in your backpack? And you have your backpack with you?
Yeah.
Okay.
It's all over my backpack.
I didn't, well, you said it like it's in my backpack, and I'm like, do you have your textbook with you? Well, it's in my backpack, just making sure.
Oh, I don't
And
got
Eric,
the
do you have your
textbook.
book with you?
Miss Kenny, you not listen. I don't have the textbook with us. I don't got it.
You don't have the
papers.
textbook?
I got the papers though. Like from yesterday, you gave me.
Okay. So, but I need to print out more papers for today. So we're gonna finish up some details about exponential functions. And then we're gonna get into the inverse of an exponential, which is a what? Inverse of an exponential, we've talked about it.
A natural log.
So we use the natural log, but just a log in general.
Yeah.
The natural log is a special type of log, but we're gonna get into logarithms as a whole. So let's head to lunch. We'll have enrichment after lunch, and then we will go to get back to class after lunch. Right,
Is
Eric?
there a clock on?
Just a couple minutes. It is 11:35 now.
That's just a
Oh, you crazy.
Jayla, can you hit the silver record button there so it stops recording?
Yeah.
It's on the back left.
Oh.
Here,